Okay, today you have two videos to watch. This is the first one you're going to watch, which is called Getting Equations into Slope-Intercept Form. So in the past, we've practiced with the equations already in slope-intercept form, but if you look at all of these down here, none of them are. So we have to make them look like this. So that's the goal for this first video. I probably won't do all of these problems. I just want to kind of pick around and do some of them, and then we'll go on and we'll do the second video after this. Okay, so I've narrowed it down to 3 easy steps. First, we're going to circle the term that has the y, and we're going to make sure our circle includes the plus or minus sign. We've kind of already been practicing this. When we solved for x, we circled everything smushed with x. The other day when we were doing the literal equations and we saw the different variables in there, we circled everything smushed with the variable we wanted to solve. So let's practice step 1. On number 1, I'm going to circle everything smushed with the y, and I'm going to make sure that I include the plus or minus sign in that circle. So like on number 2, I'm going to circle the 5y. Then on number 3, I'm going to circle this plus y. So that's what it means to circle the term that has the y and to include the plus or minus. Okay, step 2 says look only on the side of the equation where the y is, add or subtract anything outside of the circle. Okay, so I'm only allowed to look on the side of the equation where my circle is, where my y is. If anything's outside the circle, I'll add or subtract to make it go away. And we've already been practicing that. So to make this positive 3x go away, what would I do? I would subtract 3x. And I do this from both sides. 3x minus 3x is 0. I bring down what's in my circle, which is a negative 8y. On the right-hand side, I can't actually subtract these because one has an x and one doesn't. So it's recopy time. But I want to recopy the x part first. You know how in slope-intercept form, it's the y that equals, and after the equals is the x? So that's what I want. After my equal sign, I want the x. So what kind of 3x is it? It's a minus 3x, so I write negative 3x. And then I'm going to write the constant. Is that a positive 5 or a negative? It's a positive 5, so I put plus 5. Okay, and now to step 3. Step 3 says divide everything by the number in front of y. So I'm going to divide everything by the number in front of y. And what do I have in front of y? A negative 8. So that's what I'm going to divide by. And I have to do it to both sides. Negative 8 divided by negative 8 is 1. So I'm left with 1y, which I just have to write as y. Now over here it means negative 3x over negative 8 and 5 over negative 8. So I'm going to try to reduce each of these pieces if I can. Well, I can't reduce 3 over 8, but what's a negative divided by a negative? A positive. So this is a positive 3/8 x. And then I can't reduce 5 over 8, but what is a positive divided by a negative? A positive divided by a negative is a negative. So I'm going to write minus 5/8. And there's my equation in slope-intercept form. From here I could graph it. This one just wouldn't be pretty to graph because it doesn't have real nice whole numbers to work with. Okay, let's just try some more. Number 2, I circled everything smushed with my y. I look only on the side of the equals where the circle is. If something's outside the circle, I add or subtract to make it go away. So to move the positive 7x, I subtract it from both sides. Whatever's in my circle, that drops down. My equals drops down. Now it's recopy time. I can't actually subtract these. One has an x, one doesn't. They're not like terms. So first I recopy the x. This is what kind of x? It's a minus 7x. What kind of 4 is this? It's a minus 4. Okay, and the last step, I divide by whatever's in front of y. So what is in front of y? A positive 5. So 5 divided by 5 is 1. I'm just left with 1y. Now I'm going to try to reduce if I can. Does negative 7 over 5 reduce? Nope. So I leave it, negative 7/5 x. Does negative 4 over 5 reduce? Nope. So I leave that, negative 4/5. And there's my equation in slope-intercept form. Okay, I'm going to hop down to number 4 and just maybe skip around a little bit, and then we'll get to the other set of notes. Okay, number 4. I'm going to circle everything smushed with my Y, including that plus or minus sign. I look on the side of the equals where my circle is. If something's outside the circle, I add or subtract to make it go away. So what would I do to make a minus 5x go away? I would add 5x. And please make sure that you are putting the x behind these 5s. In the past, I'll see students go plus 5, but we're not plussing 5, we're adding 5x to both sides. So make sure you put your x's. Negative 5x plus 5x is 0. Whatever's in my circle comes down. Bring down the equals. And then these I can't add, I can't subtract, because one has an x and one doesn't. So like when students just go plus 5, sometimes, like if you forget to put the x there, sometimes students think that then you can add those, which you could because they'd be like terms. So just make sure that you do put the x behind the 5, because now I can't add them. Okay, so I recopy. What kind of 5x is it? It's a positive 5x, so I write a positive 5x. And then what kind of 2 is this? It's a negative 2, so I write minus 2. Okay, the last step is divide by whatever's in front of y. And what's in front of y? 8. So I divide both sides by 8. 8 divided by 8 is 1, so all I'm left with is 1y. And then I try to reduce my pieces if I can. Does 5 over 8 reduce? Nope. So that just stays 8x. And then negative 2 over 8, will that reduce? Yes, it will. To how much? Negative 1/4. And there it is, in slope-intercept form. Okay, let's hop on over to number 5. Looking at number 5, I'm going to circle everything smushed with my Y. I look on the side of the equals where my circle is. Is anything outside my circle? Yep, a minus 9, so I add or subtract to make it go away. What would I do? I would add 9 to make it go away. And I do have to do that to both sides. Negative 9 plus 9 is 0. Bring down the 7y. Bring down the equals. I can't add these because one has an x and one doesn't, so they're not like terms, so it's recopy time. Remember, I want to start with the x. So what kind of x is this? It's a positive 2x. And then the constant. What kind of 9 is this? A positive 9, so I put plus 9. Last step, I divide by whatever's in front of y. So what is in front of y? 7. And then 7 divided by 7 is 1. Left with 1y. And then I try to reduce my pieces if I can. Does 2 7ths reduce? Nope, it just stays 2 7ths x. Does 9 7ths reduce? Nope, it just stays 9 7ths. Okay. Maybe let's do 3 more. I know, you're like, no. But yeah, let's do 3 more. I'll make a smiley face. That'll make it better. All right, number 7. I circle everything smushed with my Y. Whatever's outside my circle, I add or subtract. So what would I do? To move a minus x, I would add x to both sides. Negative x plus x is 0. Bring down what's inside your circle, which is a negative 3y. Bring down your equals. I can't add these. One has an x, one doesn't, so it's recopy time. Let's start with the x. What kind of x is it? It's a positive x. And then the constant. What kind of 9 is it? It's a positive 9, so I put plus 9. The next step, I divide by whatever's in front of y. What's in front of y? A negative 3. Negative 3 divided by negative 3 is 1, so I'm left with 1y. Now sometimes this is where I'll see a student make a mistake. What does this give you? What's in front of that x you don't see right here? A 1. And then can you reduce 1 over negative 3? Nope. So it just stays 1 over negative 3. I just don't like to put my negatives in the denominator, so I'm going to put it up in the numerator, and I recopy the x. But sometimes I'll see students write this down as a negative 3x because they forget about that 1 being on top. So it's 1 over negative 3. I just don't like to put 1 over negative 3. I don't like my negative in the denominator. I just move it to the numerator. Okay, now let's reduce this piece. How much is positive 9 divided by negative 3? Negative 3. So I put a minus 3 in the back. And there's my answer in slope-intercept form. Okay, number 8. I'm going to circle everything smushed with my y. I only look on the side of the equals where my circle is, where my y is. Is anything outside my circle? No. So step 2, when it says add or subtract anything outside the circle, step 2 doesn't exist in this problem because there isn't anything outside the circle. So I move on to step 3, and step 3 is divide by whatever's in front of y. So what's in front of y? 2. So I divide both sides by 2. 2 divided by 2 is 1, so I'm just left with 1y. I'm just going to put the y on the left side, though, instead of the right. Now I'm going to try to reduce these pieces. Does 5 over 2 reduce? Nope, it's going to stay 5 over 2x. Does 8 over 2 reduce? Yep, it makes 4, so plus 4. And there's our equation in slope-intercept form. Short and sweet. But sometimes students mess up because you get so used to adding or subtracting first that sometimes when there's nothing on the side with the y, students get confused. Okay, we're going to do one more on this paper, and then we're going to move on. Number 11. I'm going to circle everything smushed with my y. Whatever's outside my circle, I'll add or subtract. So how do I get rid of a minus x? I add x to both sides. Negative x plus x is 0. Bring down what's in your circle, which is a negative y. Bring down the equals. I can't add these because one has an x, one doesn't. So recopy time. Let's start with the x. What kind of x is it? Positive. Then what kind of 9 is it? Positive. Now I can't ever leave this negative y. It has to be positive y. So this is understood to have a negative 1 in front. And so I'm going to divide both sides by what's in front of y, which is negative 1. Remember, there is a positive 1 in front of this x, you just don't see it. So negative 1 divided by negative 1 is a positive 1. All you're left with is 1y or y. What's 1 divided by negative 1? Negative 1, so negative 1x or just negative x. And then what's 9 divided by negative 1? Negative 9. Now, I want to rewrite this real quick just to talk about this a different way. So I got rid of this negative in front by dividing both sides by a negative 1, and this is the answer I got. So I just want you to know that if you know that when you divide everything by a negative, it just switches all the signs, we could kind of skip this step of showing divide both sides by negative 1. So if you ever see a negative 1 in front of your y, and you don't want to show your work, you just switch all the signs. So if I divide all these by a negative 1, this negative y switches, it becomes a positive y. This positive x switches, it becomes a negative x. And this positive 9 switches, it becomes a negative 9. So if you ever see a negative 1, just divide everything by negative 1, which just switches all the signs. Okay, first video done. We still have another one to go. Hang on.